right, guys, so standard 11, this is kind of some of the applications for your exponential and log problems. So first formula we're going to look at here is the compound interest formula. A equals P times 1 plus R over N to the N times T. So let's figure out what some of these things stand for here. All right, A is just your final amount, like the final amount of usually money that you're going to end up with. Anybody know what P stands for? Charlie, you got it? Yes, it's the initial amount. It's sometimes called the principal. Like if you make an investment, you put principal into it. Which is the initial amount. No, it's kind of small, guys. What do you think R is? Bigger. Yeah. Interest rate. What about T? Time, and I would be specific and say time in years. Okay, so if I say you invested for 18 months, you're not going to put an 18 in for T, you put like 1.5, okay? So time in years. Anybody know what N is? That's kind of the weird one. All right, it's the number of times interest is compounded per year. If you could read something, let me know. I know that's tiny.
Will we get this equation just so I can memorize the equation?
I think we'll give it to you. I'll consult with the other pre-qual teachers to confirm, but I think we'll give it to you.
Thank you.
Yes. So guys, number of times it's compounded per year. So if you see something that says interest compounded monthly, what do you think that would be? 12. What about quarterly? 4. Daily. How many days are in a year, guys?
365.
Okay, good job. All right, so it's just whatever I tell you in the problem. So let's set up the first one, and then I'll just have you key it into your calculator to make sure you understand how all of that works. All right, find the amount. So you're looking for the VA. When a principal of $100 is compounded quarterly for 3 years at 6% interest rate. So let's just fill in the rest of the variables in our equation. What am I going to put in for the P?
100.
100. 1 plus. All right, the rate. Do I put in a 6? No. 0.06. Okay, it's 6%. If you put in a 6, that is like 600% interest. You should take that investment, guys. 6.06. Okay, N, compounded quarterly. So what am I going to put in? 4. And then all of this is raised to the N times T. So we already know N is 4. What's T? 3. Okay. Try keying this into your calculator. And guys, don't do it a piece at a time. Do the whole thing. Okay? If you have an older calculator, you need to be very friendly with the parentheses. If you have a newer one, you should be able to just, it'll look just like this when you key it in. I'll give you a second to try typing it in, and then we'll see how you do on. Yep, to the power of 4 times 3.
So it would be the power of 12.
Or you can do raised to the 4 times 3, as long as the whole thing is your exponent. All right, guys, what you should end up with, well, first, what do you think we should round to, since this is money? Yeah, near cent, right? Near cent. So you should end up with $119.56. Okay. If you keyed it into your calculator and got something that was not that, raise your hand so I can come help you figure out what went wrong with you and your calculator. Yeah, it's fine. I expect this. Okay, so you have an older calculator, so you need the 4 times 3 has to be in parentheses because it's raising it to the 4th and then taking that answer times 3. Okay, so try to this is right other than your decimal, so it's like 06, and then here you made it 1100. So, that's okay. Oh, you need a second parenthesis before you do yours. So, it needs to be parenthesis 1 plus this parenthesis. You see what I mean? Try it again, see if you get it. Anybody else? That's fine. Did it work? Yes. Yeah, okay. All right, let's try the next one. Okay, how long would it take for $2,000 to double if 5% interest is compounded semi-annually? All right. So if $2,000 is doubling, how much money are you going to end up with in the end? 4,000. So A is clearly not what we're solving for, right? Like we know we're going to end up with $4,000. We know we started with $2,000. Do we know the rate? 0.05. Compounded semi-annually. What do you think that means? 2. Okay. Raised to the 2 times t is what we're looking for, right? Isn't it saying how long? Okay, so our variable is up there in the exponent. So let's look at how we would solve this. What do you think your first step might be?
Put it to get t by itself.
Okay, so what would your first step be to do that?
Divide by 2,000.
Divide by 2,000. You want to isolate whatever is raised to that exponent. So are you guys okay with me just writing 2 equals this whole thing, 1 plus 0.05 over 2 to the 2 times t? Okay, I can't like isolate the t anymore with just how it's written, right? I can't like subtract a 1 and think that's going to work out okay. You need to figure out how to get that variable out of the exponent. So what did we just learn how to do in Standard 10? Oh, logs. Yeah, okay. I'm going to go ahead and take the natural log of both sides. So we'll squeeze that in there, squeeze that in there. So the left side of my equation is just natural log of 2. The right side, where might I write that exponent of 2t? Oh, great. It's not an exponent anymore. So much easier. You with me there? Okay. Now, how do I get t by itself? Divide by everything else that's there, right? Do you see how I can divide by the 2 and the natural log of 1 plus 0.05, all of that? Okay. So I'm going to have natural log of 2 over 2 natural log 1 plus 0.05 over 2. All of that equals t. Okay. Key that into your calculator, and let's just go to the nearest year right now. So tell me about how many years this would take. Again, old calculators. You're very friendly with your parentheses.
So how do you get the natural logs and take out the thousands?
How do we get the natural logs and take out the thousands? What do you mean?
How would you just divide by 2,000?
The first step, is that what you're talking?
Yeah.
Yes, I just divided both sides by 2,000. Anybody think they got time? No? Ooh, yep, not going to be negative. That's not 1. 14. Yeah, 14. Okay. Negative. Well, it's not 1. You see it? 14? Yes? Negative 14. Yeah? Yeah.
So if you're so then so would that
Yeah, it counts. That's what it's doing. Yes, they're like, more money now. Yes. You need like more I did one more assessment there. Yeah, no problem. 14? Did you do it? Use the one on your phone. Didn't show it that way either. Or you can use the assessment. Oh yeah, yeah, you can do that. So it's like, okay. Almost like that 4 version screen. 14? You're here? Yes? You gotta check. Okay. All right, let's try again. So this was about 14. And make sure you tell me years, guys, okay? All right. There's another way that interest can be compounded. It's called continuously. So we have a slightly different formula. We have this A equals PE to the RT. I call it PERT. A is the same, it's the final amount. P is the initial amount. R is your interest. T is still time in years. But we have this lovely E in there. E is approximately 2.718. You're just going to use the actual E part of your calculator. So guys, look on the left side of your calculator. Do you see the natural log key? Look like above it if you did second and then pushed that key. Do you see how it's E to the? Yeah, okay. That's the E you're going to use. All right? So let's go through the first one. Principal 100, interest rate 0.06 times 3. Key it in, see if you get the right answer. Yeah, okay. But don't do this weird paper over like, okay, all that stuff, okay? Yep. Anybody want to say what they got? No, it should be over $100. Yep. $119.72. Okay, let's see. Okay, it's doing 119 first. All right, guys. Questions on that one? Did we get our 119.72?
Yes, why is it different than the other examples?
So it says interest is compounded continuously, right? That means okay, compound again. How many times per year is that? Like, could you put a number and be like, oh, my N is, so that's why we have this stuff. That's where okay. All right. Second one, how long would it take for $2,000 to double? All of this is the same as up above, but your interest is compounded continuously. So first, let's look. Did I end up with more money or less money when it was compounded continuously for the same interest, same amount of time? So in the first problem, it was compounded quarterly, and I ended up with $119.56. And the first continuous problem, I ended up with $119.72. So which one is the better deal for you?
Continuous.
Continuous, yeah. It's calculating your interest over and over and over and over and over. And so those little tiny amounts are getting added back in. You're making more money the more times your interest gets compounded. So up above, it took about 14 years for it to double. With everything else remaining the same other than how the interest is compounded, do you think it's going to take more or less than 14 years? Less, right? Okay, because you're earning that money just a little bit faster. Okay, so it's close, but it's a little bit quicker. So again, think about our 4,000 is doubling from 2,000. E to the rate of 0.05 times t. So that's our initial equation there. So what's the first step? Divide by 2,000. So I'm going to have 2 equals e to the 0.05 times t. Do you guys see how you have to isolate whatever's raised to the exponent? Okay. What do I do then? It's got a variable in the exponent.
To the natural one?
Natural log, good. I'm going to take the natural log of both sides. And you definitely want natural log this time because of the e that is involved, okay? Move this up a little for you. So I've got natural log of 2 equals, and can I write it 0.05 t natural log of e over here for you? Well, guys, what is the natural log of e? 1, right? Okay, so what am I really going to divide by? 0.05. If you, on your calculator, divide by 0.05 natural log of e, it's fine. It's not going to mess it up, but you don't really need the natural log of e anymore. So you have to key in natural log of 2 divided by 0.05 to get your t. And you should get like 13.9 here, so just a little bit quicker than before. So key it in, see if that's what you get. Did it work that time, right? Okay, good. If you're having calculator troubles, let me know.
So would it just be e to the first equals like
Like, where does the natural log of e go?
yeah, like is just 1 to the 0.5 times t on the right side?
It's 1 times 0.0, because remember the exponent we bring in front, so we really have
Okay.
0.05 t times natural log of e, but natural log of e is just 1. So that's why that essentially disappears. All right, guys, we okay with that one? We're doing one more, and that's it. All right, what would the rate need to be for $300 that's invested for 4 years, compounded continuously, to become $1,200? You see the word continuously, right? So that should tell you you're using the PERT formula, okay? So what's my equation going to be that I start with? 1,200 equals 300 e to the for r, right? Yeah, okay. We need a variable somewhere if we're going to solve it. How do I go about solving that? Divide by 300. So we get what? 4 equals e to the 4r. What do I need to do to both sides of my equation? Okay. So, natural log of 4 equals 4r natural log of e. Do I need the natural log of e? No. So this is just natural log of 4 divided by 4. No, the 4's do not cancel out and you're left with just natural log. That doesn't make any sense, okay? Key it in, let's see, what do you get? 0.35. Woo. Or you could say 35%. That is some serious interest, guys. Which makes sense if you want $300 to turn it into quadruple essentially in 4 years. That's a lot. Okay, questions on the money stuff? Okay, in your packet, your homework, there's standard 11 homework. There's a front and a back, and then there's another front and back. Do not do the page that starts in 1988, the population of a country was 70 million, okay? Do just the first page, front and back. So 1 through 13. We got it?
So do that picture that or just don't do it all?
We may pick and choose a few problems from it, so don't, like, you know, angrily scribble it all out. But we'll just do the money one for now. You've got 5 minutes, guys. You can start